So this question is about parallel plate capacitors and the energy stored and the electric field. So we have this situation where we've got a parallel plate capacitor charged from a source of EMF, and then so we have the initial situation where we have a voltage, a charge stored, a charge separated due to this voltage that's been applied. The voltage ends up at the same voltage as the EMF, so we have that, and we've got a separation of the plates, and then we're asked what happens. And between these, there'll be an electric field. It's a uniform electric field across them because they're parallel plates. So one side will be positive, one side will be negative, and we'll have an electric field E. And that's what we have to begin with. And then we're told that we double the separation of the plates, and we're asked what happens to the electric field strength. So we can look at it from the perspective of the equations that we have in the formula and data booklet. So we have what will happen to the capacitance, and that's the way to start this. So the capacitance of parallel plate capacitors given by A multiplied by the permittivity free space, and then the permittivity of the dielectric medium, if there is one, or whatever's in between them. They all stay constant, so the area of the plates and these two constants remain constant because it's the same material. And then we have D. So if we double the separation, because the capacitance is inversely proportional to the distance between the plates, then we've halved the capacitance. So the capacitance has halved. So bear that in mind, that the capacitance is halved. So what effect does that have? Well, capacitance halving, if we look at the capacitance is Q over V, then the capacitance halving means that if Q has to stay the same, and Q will have to stay the same because they're isolated, so the charge can't flow anywhere, then if the capacitance halves, that must be because the voltage has doubled. So the voltage V has doubled. So we've got the capacitance halving and the voltage has doubled. So in terms of the electric field strength, the final equation we need, the electric field strength is the voltage over the separation of the plates. And if the voltage has doubled, as we're told, and the separation has doubled, well, look what happens. We end up with the same electric field strength that we had before.